Hey guys, welcome to our channel CAD Solution. Today we will learn about bottom-up assembly in Creo software. First of all, let's understand what is bottom-up assembly and top-down assembly. In bottom-up assembly, parts are separately created, and in assembly workbench, parts are called one by one for the assembly. Where in top-down assembly, parts are created in assembly workbench itself using the reference of the mating parts. This is the basic difference between bottom up assembly and top down assembly. So let's do the bottom up assembly in Creo software. We will create the assembly of this gearbox in the Creo software. The part number and part names are given in the BOM, so we will call each and every part one by one and assemble it. Let's set the working directory first. I have created a separate folder on desktop, so I'm selecting that one. We have assembly number mentioned in the BOM. It is mentioned 15 here, so we'll check what is the name and number for the 15 number reducer gearbox, and its assembly number is mentioned, so we'll give the same number to the assembly. Select new assembly. I'll give the same number I've mentioned in the drawing, 5040900110. I'll select MMNS assembly design. If you want to define description and modified by, you can define here, else you can leave it as it is. So let's get started with its base part first. I think this will be housing number 1. Part number is mentioned here, so we'll call one by one by part number. Click on assemble. I have saved all the child parts in single folder. If you want this child part, I will share it on our Telegram channel, so do join our Telegram channel for this file. I will share it on Telegram channel. If you want to preview any part, so this option will be available. If you click on this preview option, then the part preview will be shown here. If you turn off, then we're not able to see that, so I'll just turn it on. So this one is the housing. Just open the housing. As this one is the first model of my assembly, so I will set it as default one. Okay, it will be by default set at the center of the assembly. So next part will be this gear or this gear. In this case, I have separately created a sub assembly of this gear, this shaft and the bearings as well. So I will directly call the sub assembly here. Call the gear and pinion assembly. Assemble. Select sub assembly here, so that only sub assemblies will be shown here. So this assembly we will assemble. Open. If you want this part to be open in the separate window, then this option is available for the same, so that you can zoom in and zoom out it in separate window. So go to the placement. If you want planes for the parts, you can turn it on from here, or you can select from here also. So I will select the first plane of assembly, select the front plane for assembly, and then for component I will select the right plane. So as of now it is by default taking as a normal, but I don't want it normal. I will take it as a coincidence. The center of this housing and center of this gear will be coincide, means it will be at the center. Next constraint will be the diameter of this shaft and this hole. I will make it as coincidence. As of now the assembly is showing as fully constrained because it has taken some assumptions. I don't want that assumptions, so I will untick this option. See, still this degree of freedom is available, so we will lock that one as well. I want this output shaft on this direction, so let's flip the assembly. I have given coincidence to both the planes, so I will flip that one. So it is now flipped. Take new constraint, and now we can take this diameter of the bearing and this diameter of housing. It is mentioned as fully constrained. Click OK. So our next part will be the cover. Call the cover in the assembly. We'll check one by one, or you can directly search part number from here. If you have part number like I have, So only this part will be appear here, and from here you can call it. Again give placement to this cover. As of now I'm giving the constraint for planes. I'm using planes for the constraint. Assembly plane will be front plane and the plane for cover will be white. If we coincide it, the right plane is not correct, so I will remove it from here also. Go to the front. If it is correct, then it will show it here. If not, then you can remove and again give it accordingly. So next constraint will be this face and this bottom face of the cover. I'll select this face and bottom face of this cover. Automatically it is taking coincide. So I want coincide only, so I will not change it from here. So still it is partially constrained. You can see the arrow is highlighted here in red color, so we can still have 1 degree of freedom is available. So what we can do is we can give the constraint to this hole and this hole or this bearing diameter as well, or else we can give the constraint to this hole and this bolt holes as well. So both way you can use. I am defining this diameter and bearing diameter as a coincidence. Now it is fully constrained. Click OK. Let's call next part this top lead 9 number. So we have number 5040005 Search here 210. This one is that cover. That part will be similar from both the sides, so we can take any of the side as we want. So first I will give the constraint for this face and this bottom face of this cover. I want the coincidence. So now next will be the constraint for the holes. I will take the constraint for this hole. If you want this axis of this hole, then you can turn on the axis from here as well, but I don't want axis. I will directly take the reference of the hole. Take the reference of this hole and this hole. Take new constraint for this hole and this hole. Orientation it will take. Coincidence is not possible because coincidence already given for this, so this will be considered as orientation. Now it is fully constrained. Click OK. Now assemble this 16 member plug. Part number for that plug is 019, last digit. Call that plug in assembly. Search for part number. The location is here, so I will give the coincidence first, this surface and this hole. Again give new constraint, this surface and this surface. It is taking angle offset. I want coincidence instead. Select coincidence. As of now it is partially constrained and one more constraint required for this. I will select assembly front plane and one more plane will required for component. I will select front plane for this component. Give parallelism. It is already by default selected. Click OK. Let's assemble screw 23 number. This number is 109, single quantity. Give the coincidence constraint to the outer surface of this board and the hole. New constraint for this face and this face of this housing. Instead of distance, give coincidence. So I don't want this direction, so I will flip it from here one more constraint is required. If you don't want to define it, you can directly click on this option, allow assumptions. I will define it here, front plane, and select the front plane for this bolt. You can define coincidence, but instead of coincidence, take parallelism. As of now, it is in center, so it is taking coincidence. If the hole is somewhat shifted from the center, then parallelism will be best for this case. Let's call the next part end cover 7 numbers 005110. Call end cover in the assembly. It is 005110. This one. Define constraint. I will give the coincidence to this outer dia and this inner dia of this hole. I'll again give the coincidence constraint for this hole and this hole. Sorry, it will be oriented constraint. New constraint will be this inside face of this end cover and this face of housing, or you can select this face of cover as well. So I will select this one. Instead of normal, give coincidence. It is fully constrained now. Call for its bolt number 20 number bolts, 343106, quantity 12. But here we can see 1 2 3 4 5 6 quantities are there, but in BOM 12 is mentioned, so it may be for this 6 here, 6 here, 343106. Give the constraint like outer diameter of this bolt and this hole. New constraint like this face and this face of this bolt. I want coincidence, but not in this direction. Clip the direction from here. As of now, still it is partially constrained. One more constraint is required. Give one more constraint. Right plane you can select from here. And for this front plane, if possible, you can give parallel constraint, so it will be fully constrained. Again, I need 5 more quantities of the same bolt here, so instead of calling it one by one, I will simply repeat the bolt. Select the part, right click and click on repeat. This coincidence we have given to the bolt diameter and the hole. This coincidence is between this face and this face of bolt head, and this one is the parallelism between two planes. So as of now, planes and the face will be common here, so only we need to change this coincidence. So I'll just select and click on add, and after that just click the holes 1 2 3 4 and 5. Click OK. And if you can see here, if you can edit, all the constraint will be copied from previous one. Only first constraint will be changed, that is the diameter of bolt and hole. Remaining will be same as the previous one. So next part will be this open end cover number 10. Check the number. End cover open 5040, 10 number 400. Call that end cover. This end cover, I'll open it in separate window. Give the constraint, this outer diameter to the inner diameter of this hole. Again, new constraint will be orientation, this hole to this hole. New constraint will be this face and this face not normal. I want coincidence. Now it is fully constrained. Now this bolts, as of now number is not mentioned, so we'll copy the same bolts from this side, 22 number, that is 343108. Give the constraint this diameter to the hole, this space to this space. I want coincidence here. You can change it from here as well. I'll select from here, flip the direction. Still it is not fully constrained. New constraint, again right plane, select front plane and make it parallel. Now it is constrained. Repeat the bolt, right click and repeat. Again same thing here. I will only select this coincidence and add. If you want to change more constraint, then select them all at a time and click on add. So I will select first one and just select the references. First, second, third, fourth and fifth. Remaining constraint will be copied as is. So now assemble this end cover number 8, 112. Call the end cover, open, give constraint this outer diameter to this inner diameter of that hole, this face to this face. Again I need coincidence for this. One more constraint for this hole and this hole, and now it is fully constrained. Now assemble this bolt number 22, 343108. Search for that bolt, open, define the constraint, new constraint, this face to this face. I will define coincidence, define the plane, and select right plane and the front plane of that bolt and parallelism. Okay, repeat that bolt, right click, repeat, select the constraint, click add and just select the references. Okay, so assemble this end cover 11 number 005402. This one, open, define the constraint, outer diameter to the inner diameter. I need coincidence, define another constraint, this face to this face. I need coincidence and one more constraint for this hole and this hole. Now it is constrained. Now assemble this bolt number 20, 343106. I think we have already added this bolt in the assembly, so let's check first. This one is not that, not this one, yes, this one. So what we can do is we'll again repeat the same thing, click on repeat. This time we will select two constraints from here because our surface will be changing here. this one and this one. Click add. Just select the references. First one will be this hole. Press Ctrl, the surface. Again, hole and surface. Select hole. Press Ctrl and this surface. Hole, control surface. Hole, control surface. Hole, control surface. That's it. Now assemble this bolt. 19 number 343105. Use constraint this diameter to this hole. New constraint this face to this face. I need coincidence. Flip the direction. One more constraint we need to define. I'll select front plane, and for this front plane, make it parallel. Click OK. Again repeat that bolt 5 times. Select single constraint only. Click on add. Select the hole. Now assemble this bolt of 24 number 343110. 4 quantities. So we have different bolt here. 1, 2, 3, 4. So these 4 bolts we will assemble first. Define the constraint. So this space to this space. Flip the direction. Define one more plane constraint. Front plane to the front plane. Instead of coincidence, define parallelism. Click OK. And repeat that bolt. Select the first constraint. Add. And select the references where you want to repeat that bolt. OK. Again this bolt number 21 quantity 6. Call the bolt. Define constraint. Face to face constraint. Flip the direction. Define one more constraint. Front to front. Instead of coincidence, define parallelism. Click OK and repeat for remaining instance. Add. OK. Now assemble this bolt number 21 343107. Define the constraint. Face to face constraint. Flip the direction. Another constraint, front plane to front plane. Parallelism instead of coincidence. Repeat that bolt for remaining positions. Add. Select references. Here no need to press Ctrl button. Without pressing Ctrl you can select the references. Assemble this washer number 25 230. Search for the washer. Open. Define the constraint. Inner diameter at washer and outer diameter of this bolt. This space to this space. Instead of distance, define coincidence and one more constraint for plane. Front plane to front plane. Instead of coincidence, define parallelism. Click OK. So here first we will repeat this washer for 6 numbers and then for 4 numbers because of this surface, and this surface is different one. Let's repeat. Select this constraint, click add, and the references first, second, third, fourth and fifth one. Again we will repeat this washer for 4 numbers. Repeat. This time our 2 constraint will be changed. Add. The selection of the references should be seen as the coincidence defined previously. So select this surface and this face. Here you need to press Ctrl after first selection. So select this surface, press Ctrl and the surface. Here this diameter and press Ctrl this surface, this diameter, press Ctrl this surface. That's it. So this is how you can create bottom-up assembly in Creo software. Check out our this videos for more. Don't forget to subscribe our channel and do join the Telegram channel for more updates and the content related to design engineering. Thank you for watching.